or otherwise velocity time graph. There are three types of speed time or velocity time graphs. One is the one that represents constant speed, which is giving no acceleration. Another one is representing uniform acceleration. And the third one is representing non-uniform acceleration. We'll take up each case and see how are the graphs represented and what quantities can we derive from the graph. Constant velocity graph. Consider a car moving in a highway with a constant speed of 40 km an hour. For any interval of time, when we see the car will be in a constant speed of 40 km an hour. If this point represents 40 km an hour velocity in y-axis, then even if the time passes, the car will be in the same velocity. Therefore, the graph will be a straight line. Now, what all quantities can be derived from this graph? Let's say I have a time interval of t1 and t2 in the graph such that I need to find the distance traveled by this car in between the time interval t1 and t2. Therefore, to find the distance, I am joining this line with t1 and t2. Therefore, I get a rectangle ABCD. Then, the area under this rectangle ABCD gives you the distance traveled by the car with velocity 40 km an hour in between the time interval t1 and t2. That is, area is equal to length into breadth. The length here is 40 km an hour and breadth here is t2 minus t1. Therefore, you get the distance traveled by the car in between the time interval t1 and t2 from a constant velocity graph. We know that for a uniform acceleration graph, the graph between the velocity and time will represent a straight line. Why? Because the change in velocity will be equal amount with respect to equal amount of time. Therefore, you get a straight line. Now, can we find the distance traveled by two objects in between the time intervals t1 and t2? Yes. How? Let us join this line with t1 as well as t2. Now, the area under this will give you the distance traveled between t1 and t2. How do you find the area under this kind of graph? Let us split this graph into a triangle and a rectangle. Say A, B, C, D, E. Then the total area under this line will be area is equal to area of the triangle ABC plus the rectangle BCD. Now, what is the area of the triangle formula? We know that area of the triangle is nothing but half into base into height plus the rectangle formula is nothing but length into breadth. Now, tell me what is the base and height here? Base is nothing but BC and height is nothing but AC. Therefore, you get area as half into AC into BC plus the area under the rectangle is nothing but BD into D. BD into D, which gives you the total distance travelled within the time interval t1 and t2. Non-uniform acceleration. Non-uniform acceleration is nothing but whenever there is a change in velocity which is in unequal amounts with respect to time, then the graph will represent a non-uniform motion. That is, anything except a straight line in a velocity time graph gives you a non-uniform motion. Let's try to do the activity. In the activity number 1, they have given the distance travelled by two persons, that is Feroz and Sania, within a specific amount of time. Let's try to plot a distance versus time graph using the data. When you plot a distance versus time graph using this data, both the data gives you an example for a non-uniform velocity. In the next activity, the arrival and departure of trains in 3 different stations is given with the distance of every station from station A. Now, try to plot the distance versus time graph considering that the train travels with a uniform velocity. Then, if you try to plot this data, you should get a graph like this. Try to plot this and see if you get this.